Hi friends, I'm Harpreet Singh Walia, having 20 plus years of experience in information technology. I'm SnowPro Core certified, and today I'll take you through the architecture of Snowflake and why organizations should use the same. Snowflake has its unique and innovative architecture. Snowflake is architected with three independent layers: cloud services, multi-cluster compute, and centralized storage. Let's discuss each layer in detail. Snowflake, as a cloud-based data warehousing platform, has a cloud service layer that plays a crucial role in managing and orchestrating various aspects of the system. The cloud service layer in Snowflake is responsible for several key functions. Cluster management: the cloud service layer is in charge of managing and provisioning clusters of compute resources. These clusters are used to process queries and workloads submitted by users. Snowflake's architecture allows for automatic and elastic scaling of clusters to ensure optimal query performance. Query optimization: Snowflake's cloud service layer is responsible for optimizing SQL queries. It analyzes query plans and optimizes the execution of queries by distributing workloads efficiently across the available compute resources. This helps ensure that queries are executed as quickly and cost-effectively as possible. Metadata management: Snowflake maintains metadata about the structure and organization of data within the data warehouse. The cloud service layer manages this metadata, allowing users to easily define and manipulate tables, views, and other database objects. Data distribution: Snowflake's cloud service layer handles data distribution and organization across the underlying storage. Data is stored in an object store, like Amazon S3, and is efficiently distributed across storage locations for performance and redundancy. Security and access control: the cloud service layer enforces security and access controls. It manages user authentication, role-based access control, and encryption of data at rest and in transit. It ensures that only authorized users and roles can access and modify data. Query compilation: when a user submits a query, the cloud service layer compiles the query and generates an optimized execution plan. This plan is then used to direct the compute resources to process the query. Data sharing: the cloud service layer also plays a role in data sharing. It facilitates the secure sharing of data with other Snowflake accounts or external parties. This includes controlling data access, enforcing security policies, and tracking usage. Monitoring and logging: Snowflake's cloud service layer provides tools for monitoring the performance and health of the data warehouse. It generates logs and metrics that help administrators and users track the execution of queries and system activity. Resource management: the cloud service layer helps manage resources efficiently, ensuring that the available compute resources are allocated effectively among different workloads and users. This includes managing workloads to avoid contention and ensuring that high-priority queries get the necessary resources. Workload management: Snowflake offers workload management features that allow users to define and manage query priorities, ensuring that critical workloads get the required resources and meet service-level objectives, SLOs. The cloud service layer in Snowflake is at the core of its architecture, abstracting much of the complexity associated with traditional data warehousing. It enables Snowflake to provide a highly scalable and user-friendly platform for data storage, processing, and analysis in the cloud. Users interact with Snowflake through its web-based interface or via SQL queries, while the cloud service layer handles the underlying infrastructure and management tasks. In Snowflake's architecture, the compute layer plays a crucial role in processing and executing queries and workloads submitted by users. The compute layer is responsible for dynamically allocating and managing the computational resources necessary to perform data processing tasks efficiently. In this diagram, you can see we have four data warehouses defined with different size. A virtual warehouse is a cluster of compute resources used for processing queries and performing data operations. The size of a virtual warehouse, often referred to as its size, determines the amount of computational power available for processing queries. Snowflake offers different virtual warehouse sizes to accommodate various workloads and performance requirements. When you provision a virtual warehouse in Snowflake, you can choose from different sizes or tiers based on your specific needs. These sizes are generally categorized based on the amount of CPU, memory, and concurrency they offer. Snowflake provides several predefined sizes for virtual warehouses, and you can select the one that best fits your workload demands. The available virtual warehouse sizes may vary depending on your Snowflake service plan and the cloud platform, Amazon Web Services, Microsoft Azure, or Google Cloud Platform, you are using. Common sizes include XSmall: this is the smallest size, suitable for light workloads and development/testing purposes. Small, medium, large: These sizes offer progressively more CPU and memory resources, allowing for handling more complex and resource-intensive queries. X-large, 2x large, 3x large, these are larger sizes designed for heavy workloads, large datasets, and high concurrency. They provide substantial computational power for complex analytical processing. Elastic clusters. Snowflake also offers elastic clusters, which allow you to dynamically add or remove clusters based on workload demands. This provides auto-scaling capabilities, ensuring optimal performance during peak usage times. It's important to choose an appropriate virtual warehouse size based on factors such as the complexity of your queries, the volume of data you're processing, and the level of concurrency your workload requires. Keep in mind that you can resize virtual warehouses dynamically to adapt to changing requirements. For example, you can scale up to a larger size during periods of high demand and scale down during periods of lower activity. This flexibility allows you to optimize costs and performance based on your specific needs. Centralized storage. Snowflake uses a multi-cluster, shared data architecture. This allows multiple users and workloads to access the same data without performance degradation. Snowflake separate storage and compute resources. This means that your data is stored separately from the computing resources used for processing queries. This architecture allows for better scalability and flexibility. Relational. Snowflake, as a cloud-based data warehousing platform, uses a relational database model for storing and managing data. Data in Snowflake is organized into tables, which follow a relational structure. Tables consist of rows and columns, similar to a traditional relational database. Snowflake uses schemas to organize database objects, such as tables and views. Schemas help to logically group and manage related objects. Snowflake supports SQL, structured query language, which is the standard language for interacting with relational databases. Users can use SQL to create, read, update, and delete data in Snowflake tables. Compression. Snowflake uses columnar storage and automatic data compression to minimize storage space and improve query performance. The use of columnar storage and automatic compression results in significant storage savings. Compression reduces the amount of physical storage required for the same amount of data, which can be crucial for managing large datasets in a cost-effective manner. Encrypted. Snowflake takes security seriously, and it provides several features to help ensure the confidentiality and integrity of your data. Encryption is a critical aspect of Snowflake's security model, and it is applied to various components of the data storage and transmission process. Snowflake encrypts data at rest using industry-standard AES-256 encryption. This encryption applies to the storage layer, ensuring that your data is protected even when it is stored on disk. Snowflake encrypts data in transit using TLS, Transport Layer Security, for all data moving between the client and the Snowflake service. This helps protect data as it travels over the network. Columnar storage. Snowflake is a cloud-based data warehousing platform that uses a columnar storage format for efficient storage and query processing. The columnar storage architecture is a key factor in Snowflake's ability to provide high performance and scalability for data analytics workloads. In a columnar storage model, each column of a table is stored separately, allowing for more efficient compression and retrieval of data for analytical queries. Data versioning. Snowflake offers a feature called time travel that allows you to query historical data at different points in time. While not exactly version control, it can help you recover data from specific points in time. Snowflake provides features like time travel and versioning, allowing users to access historical versions of data. This is useful for auditing and recovering from accidental changes. Why Snowflake? Snowflake is a cloud-based data warehousing platform that has gained popularity for several reasons. Here are some key reasons why organizations choose to use Snowflake. Scalability. Snowflake is designed to be highly scalable, allowing organizations to easily scale up or down as their data needs change. This makes it well-suited for businesses with varying workloads and data volumes. Performance. Snowflake's architecture is optimized for performance. It separates storage and compute, which means you can independently scale these components, leading to faster query performance. It also uses automatic indexing and optimizations to enhance query speed. Data sharing. Snowflake's data sharing is a feature that allows organizations to easily and securely share data between different Snowflake accounts or even within the same account. Security. Snowflake offers various security features, including encryption at rest and in transit, role-based access control, and auditing, which help organizations maintain the privacy and integrity of their data. Ease of use. Snowflake is known for its user-friendly interface and SQL compatibility. It's relatively easy for data professionals to learn and use, which can reduce the learning curve and improve productivity. Multi-cloud support. Snowflake is cloud agnostic, meaning you can deploy it on multiple cloud platforms, such as AWS, Azure, and Google Cloud. This flexibility allows organizations to choose the cloud provider that best suits their needs. Zero maintenance. Snowflake handles many administrative tasks, such as hardware provisioning, patching, and upgrades, behind the scenes. This zero maintenance approach frees up data teams to focus on data analysis and innovation rather than managing infrastructure. Data integration. Snowflake supports various data integration methods, including ETL, extract, transform, load, processes, and data ingestion from a variety of sources. This makes it easier to consolidate and analyze data from different systems. Cost efficiency. Snowflake's pricing model is based on actual usage, allowing organizations to pay only for the resources they consume. This can lead to cost savings compared to traditional on-premises data warehousing solutions. Data sharing and collaboration. Snowflake's data sharing capabilities make it easier for organizations to collaborate with partners, customers, and other stakeholders by securely sharing data without the need for complex data exports or transfers. Thanks for watching. Please subscribe if you like my work, and I'll keep getting more informative tutorials like this. See you in the next tutorials.